In this video, we're going to learn about a new coordinate system. And the reason we do that is because an object which is moving in a circle is very difficult to analyze if we try to stick with our regular Cartesian coordinate system. So the RTZ coordinate system stands for this. R is radial, T is tangential, and Z is the Z-axis. Okay, now what makes the RTZ coordinate system special is that it follows the particle. Typically, whenever we look at coordinate systems, what we have is a particle which is moving, it's changing its position within a coordinate system. But here, that's not what we have. What we have is a coordinate system which is attached to the particle itself. In order to help you better see what's going on with the RTZ coordinate system, let's consider the case where we have just a horizontal circular motion. You're driving your car at an intersection, you're just going around a corner, and when you do that, you form that circular path. Now, there are two different ways of looking at this motion which is happening. You can look at it from a helicopter view, or what is typically a top view, and then we can look at it from the side as though you were standing on the side of the road watching this person drive around the corner. Now, from the top view, you would see the bend in the road. Remember, this is like a helicopter view. This is what you would see. And so, you might be able to define a direction as north is up and south would be down, east, and then west, because it's like you're looking down at a map. And if you have a car located right here, and let's just say that the car is moving in this direction here, then we will define the radial dimension as being that. In the positive direction, the R dimension points towards the center. The tangential dimension is going to be tangent to the path, and so this would be the positive tangential dimension here. And the Z-axis is perpendicular to the page. Now that's something that we cannot see here. So that's where the side view becomes important. And in the side view, the car is going to be located right here, and we would have the R dimension is going that way. The Z-axis is going to be pointing up and down. Okay, so that's the Z dimension. And then the tangential dimension is coming out of the page at you or going into the page. It's going to be perpendicular. Okay, so radial is easy to see because it forms the radius of the circle. Tangential means it's tangent to the circular path. And then the Z-axis is going to be perpendicular to the plane that would be created by R and T. Okay, now there are some terms which get to be a little confusing in circular motion. And that's because these terms are used incorrectly an awful lot in the everyday vernacular. So those are going to be the terms of centripetal and centrifugal. All right, now centripetal means center seeking. And centripetal is the positive direction in the RTZ coordinate system. Centrifugal means center fleeing, and it is the negative direction in the RTZ coordinate system. So one way to think about it is in a normal coordinate system, we would say things like up, north, right, or east is positive. Well, we're not in a Cartesian coordinate system, so we can't really say that. But if we're using an RTZ coordinate system, we would say, oh, the centripetal direction. because centripetal is pointing towards the center. That's the positive direction. And the centrifugal, spelled with a G, the centrifugal direction is just the negative direction. So looking at my diagram above, we could see that this arrow is drawn in the positive direction. It is centripetal, whereas if I drew this arrow, it's pointing away from the center of the circle, so this is the negative direction, and it would be considered centrifugal. So the thing to keep in mind is that these two terms are only adjectives to describe a direction. They are not talking about making a new force of any kind. They're simply adjectives which describe a direction. When we talk about a centripetal force, all we're saying is, what is the force, what is the name of the force which is pointing towards the center of the circle? For example, if you twirl a ball on a string, so we have a string and there's a ball on the end of that string and it's moving in this direction. What force is centripetal? In other words, what force is in the positive direction? Now, go ahead and think about that right now. The first thing you need to do is draw an FBD. And it doesn't really matter whether or not this is horizontal or vertical circular motion, because what we're interested in is basically that there are two forces, and there's only one in particular that we care about. So there's going to be one force which is located right here, that is the tension force. And then if you have this going in a vertical circle, then we would say that there's a force of gravity pointing straight down. So what force is the centripetal force, or what force points towards the center of the circle? Because remember, centripetal is only an adjective to describe the direction of the force. Okay, that would be the tension force. We've only got two forces that are acting on this object. Let's try another one. If you're swinging a bucket of water in a vertical circle, you're swinging it over your head, what force is keeping the water moving in a circle? Okay, so the first thing we need to do is draw an FBD, and we said that this is going to be a vertical circle. So here's our bucket, and our bucket's going to be filled with water. And that bucket has a handle, and there's a string tied to it. So here's our handle here, and there's our axis of rotation, if you want to call it that, and the bucket's going to be swinging left or right. First thing we have to do is draw an FBD for the bucket. And so using my bucket as the FBD, we have the, or I should say we should be drawing an FBD for the water. I guess we can look at this a couple ways. If we're looking at just the bucket itself, then we would have, using the handle as our object to represent the bucket, we would just have the tension force pointing down, and then we also have the force of gravity pointing down. So guess what? We have two forces that are centripetal, right? Because remember, centripetal just means that it points towards the center. It's no different than saying down. It's just when we say centripetal, we mean specifically the positive direction for circular motion. We do not have any other forces acting on the bucket as a whole. There are no other forces. So that means we don't have any centrifugal forces that are acting. And centrifugal would only mean that the force is pointing in the negative direction. Now, if we analyze the water itself, then we have two forces once again acting on the water. The first is going to be the force of gravity, and then the other force which is acting on the water would be the force due to the bottom of the bucket.